Mr. Clown here from BIDMAS. This is your ultimate 2023 exam revision playlist. So we're going to start off with the complete numerical skills you need for 2023. This includes Surds, Indices, Standard Form or Scientific Notation, Rounding, Reverse Percentages, Appreciation, Depreciation and Fractions. So you can see here from SQA we've got working with Surds, which includes simplifying and rationalising denominators. We've got simplifying an expression using all the laws of indices. We have to round to significant figures. We have to work with reverse percentages, working backwards. We have to work with appreciation and compound interest and depreciation. And we've got all the things we need to do with fractions, adding, subtracting, times and dividing, multiplying out brackets.
Simplifying surds. So I've got square root of 50 and I want to simplify it. So I'm looking for two numbers at times together to make 50. One of them has to be a square number. So I've got the option of 1, 4, 9, 16, 25, 36 and so on. To find a square number, you just take a number and times it by itself. The answer is a square number. So 25 goes into 50, so I can write that first, times 2. I then just square root my 25 to get 5 times root 2. So that is 5 root 2 simplified. Let's do another one, root 96. So I'm looking for two numbers at times together to make 96. If you do that, you'll get 16. And how many times does 16 go in? Well, it goes in 6 times. So the square root of 16 is 4. So it's 4 times root 6. Or 4 root 6 is the final answer. Always find the biggest square number that goes in. If I'd used 4 there, then I would have had to simplify again at the end. In multiplying surds, so if you've got two numbers with a root and you want to times them together, you can just times the numbers that are under the root. So I can just do the square root of 5 times 15. That's the square root of 75. But if you can simplify it, you then simplify it. So square root of 75, well that's just 25 times 3. Square root of 25 is 5. So there we go, 5 root 3 is our final answer. Let's try another one. Square root of 10 times 12. So that's the square root of 10 times 12. That's 120. So you're looking for a square number that goes into 120. Quite quickly you'll get down to 4. 4 is the only square number that goes into 120. So I can write that as the square root of 4 times the square root of 30. Since 4 is the biggest one that goes in, I know that root 30 is simplified already. Square root of 4 is 2. So we've got 2 root 30 and we're done. Dividing surds. So if you've got a square root divided by a square root, then that's the same as doing one square root with the numbers divided by each other. So the square root of 48 divided by 3, well 48 divided by 3 is 16. So we've got the square root of 16, which in this case is just 4. You simplify at the end, which in this case is a whole square number. Adding and subtracting surds. You can only add and subtract surds if the number under the square root is exactly the same, otherwise you can't add them. But you can sometimes simplify a surd to make it look the same, or both surds. So let's have a look at this example. Root 50 plus root 8. Let's just at the side root 50. That is 25 times 2. So that gives me 5 root 2. Let's do the same thing with root 8. That is 4 times 2. Square root of 4 is 2. So that's 2 root 2. So this whole sum becomes 5 root 2 plus 2 root 2. Well, that's fine. 5 root 2 and another 2 root 2 makes 7 of them. So I've got 7 root 2 in total, and we're done with that one. Okay, a little past paper question, 2014, paper 1, question 8. Root 40 plus 4 root 10 plus root 90 as a surd in its simplest form. Can't add them until we're all simplified. So let's start with root 40. So we've got root 40. Well, that's just 4 times 10. 2 root 10. Notice how root 10 has appeared, and we now know that root 10 is already simplified because 4 is the biggest square number that goes into 40 and it gave us root 10 as an answer. So I don't have to try and simplify my root 10. So I'll now go and simplify my root 90. Well, that's 9 times 10. Square root of 9 is 3, so that gives us 3 root 10. So our whole sum simplifies into 2 root 10 plus our 4 root 10 that was already there, plus an extra 3 root 10. So adding all them together, 2 plus 4 is 6, plus another 3 is 9. Our answer is 9 lots of root 10.
Rationalising the denominator, that means to make the denominator a number rather than a root. So the easiest way to do that is to times by the denominator on the top and the bottom, like it's timesing by 1. So in other words, for this first one, I would times by root 2 on the top over root 2 on the bottom. Root 2 over root 2 is 1, so I'm not changing anything. So that gives me 4 lots of root 2 on the top, and root 2 times root 2 is just 2, because it's root 4, square root of 4 is 2. Now we can simplify it because 4 divided by 2, so I can divide by 2 to get 2, divide by 2 to get 1. So the answer is 2 root 2 over 1, or just 2 root 2. So that's a simple example. Let's look at a harder one. 4 root 20 over root 8. There's 2 ways to do this. You can either simplify the surd on the bottom first, or you can just go ahead and straight away times. I prefer to simplify first because it makes the maths a little bit easier later on. So if I at the side write root 8, well, that equals root 4 times root 2. 4 times 2 is 8. Square root of 4 is 2, so that's 2 root 2. So I'm going to use that for instead of my root 8. So I've got 4 root 20 over 2 root 2. Let's go ahead and simplify that straight away. When 4 divided by 2 is 2, so that gives me 2 root 20 on the top, all over root 2. Let's times the top and bottom then by root 2 over root 2 again. So that gives me 2 times root 40 all over 2, because root 2 times root 2 is 2. 2 divided by 2 is 1, so that's just root 40. But you can simplify that because 4 times 10 is 40, and 4 is a square number. Root 4, root 10, which is 2 root 10 for your final answer. Okay, 2018 paper 1, question 11. Express 9 over root 6 with a rational denominator. So we start with 9 over root 6. We times by root 6 over root 6. So this gives me 9 root 6 on the top over just 6 on the bottom. I can simplify the number parts by dividing by 3. 3 goes into 9 3 times. 3 goes into 6 twice, leaving 3 root 6 on the top and 2 on the bottom for our final answer. 2019 paper 1 question 12 was root 2 over root 40 expressed as a rational denominator. So I'll start off by simplifying my root 40 because that will make my maths easier. That is the square root of 4 times the square root of 10. Remember, I'm finding the highest square number that goes into 40. If you try any more, 25, 36, they don't go in. So that gives me an answer of 2 times root 10. So I've now got root 2 over 2 root 10. So I can times by just the square root part on the bottom, root 10 over root 10. 2 roots together, root 2 times root 10 is root 20 over 2 times, 2 still hanging about, and then root 10 times root 10 is just 10. So that gives me an answer of root 20 over 20. Now you might think you're done there, but this was a 3-mark question, so that's a little clue there. But root 20 you can simplify, so we need to go ahead and do that. So at our side, root 20 is root 4 times root 5, which is 2 root 5. So we can now use that up here to write 2 root 5 over 20, and simplifying the 2 over 20 to 1 over 10. That gives us a final answer. Put it in a box of root 5 all over 10. If we take a to the power of x and times it by a to the power of y, in other words the base is the same, then you can just add the powers a to the power of x plus y. Let's see that in an example. A cubed times a squared, so that would be a to the power of 3 plus 2, which is a to the power of 5. Second example says 3b to the power of 5 times 4b to the power of negative 2. Don't be tempted to add the 3 and 4 here. They are not indices. They just get times together as normal. So 3 times 4 makes 12. And we've got b to the power of, well, 5 and minus 2. So that equals 12b to the power of 3. 12b cubed. Okay, so if we take a to the power of x and divide by a to the power of y, so a is the same number, then we can just take away the powers. Remember, this only works if the base is the same. So the same number on the bottom or top for your indices or the same letter. So let's look at a simple example. 6a7 over 2a5. Well, I can do 6 divided by 2 first to get 3, and then we've got a to the power of 7 minus 5. So that is 3a squared. Nice and simple. Next law of indices in National 5 2022 exam, a to the power of x to the power of y. So that is just a to the power of x times y. You can just times the indices together as long as that base is the same, that a. So let's take the example of a to the power a cubed to the power of 4. That is the same as doing a to the power of 3 times 4, which is a to the power of 12. Negative powers, a to the power of minus x is the same as 1 over a to the power of x. Let's look at that as an example. Let's say we had 2a to the power minus 3 and we want to change it to a positive power. Then our 2 can stay where it is, but it's over a cubed. Negative 3 is turned into positive 3 underneath the fraction. One last thing you should be aware of is that also a to the power of 0, anything to the power of 0 equals 1. That is a key thing to be aware of if you ever need it. Okay, laws of indices. A to the power of 1 over n is the same as the nth root of a. Now I'm just going to start with when it's 1 on the top. So a to the power of 1 over 2 is the root of a to the power of 1, because it's a, and then square root. So square root doesn't need a number outside, so it's just a square root of a. A to the power of a half is a square root of a. What about a to the power of a third? Well, that would be a root with an a, but then it's a cube root because the 3 is on the denominator. Let's apply that where the number on the top is not 1 and see what happens. So a to the power of m over n is just the nth root of a to the power of m. That looks a little bit complicated, but how you do these is a to the power of a fraction, draw a root sign, write your letter, and the top number goes along with the letter. So that's a cubed, and then it's a square root. Now, I always write that, but then get rid of the 2 if it is a square root, just to write the square root of a cubed. So square root doesn't need a 2, only other roots do. Let's look at a to the 2/5 then. So that is a root, a to the 2, because the top number's 2, and it's the 5th root. So I've done that one. Okay, simple past paper question here. This is from 2014, paper 2, question 8. So it is a calculator question, even though you probably don't need it. So you've got simplify n to the power of 5 times 10n over 2n squared. So that is the same as n to the power of 5 times 10n, well that's a power of 1, over 2n squared. So let's just deal with the top and bottom separately. So doing the top, we've got 10n 6. Add the powers, over 2n squared. 10 divided by 2 is 5n, and I can take away the powers now. 6 minus 2 is 4. Okay, this question comes from 2018, paper 2, question 15, quite late in the paper, a little bit harder. It says 2/3 P4, all squared. Now, we need to be aware that we'll have to square the whole number part first. Any numbers in front get squared as normal. The laws of indices only apply to the thing with indices in it. So we've got 2/3 P4, all squared. So I need to square my fraction. So 2 2s is 4 over 3 3s is 9. P, and we times the powers. 4 times 2 makes 8, and we're done there. 2016 paper 2 question 10. Simplify n squared cubed times 10 to the n to the minus 10. Give your answer as a positive power. So let's start with the n squared cubed. That gives me 2 times 3 is 6 times n to the minus 10. Times in indices, which means we can add the powers. So that gives me n, 6 take away 10 is negative 4. Leave your answer as a positive power. The last little thing then, 1 over n to the 4. 2015, paper 1, question 14. Evaluate 8 to the power of 5/3. So I need to know what that means. That equals a root 8 to the power of 5, and it's a cube root. Now you might be thinking to yourself, this is non-calculator, how am I going to do 8 to the power of 5? But you can cube root first, that is okay as well. So I can cube root the 8, 2 times 2 times 2 is 8. So that just gives me 2 to the power of 5. I've cube root to 8. Now I can do that sum quite easy. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So there my final answer is 32. Express 1 over the cube root of x in the form x to the power of n. In other words, a positive power with a number. So first of all, that is 1 over, well, the cube root of x is x to the power of 1/3. Because there's no power on the x, so it's just 1, and it's cube root, so it's over 3. Now that becomes, using the rule, that a fraction turns into a negative power, x to the negative 1/3. And we're done. 2019, paper 1, question 16. A to the power of 4 times 3a over root a. So we'll do this in stages. Let's do the top first. I'll put a little 1 on that so it's obvious. A to the 4 times a to the 1 is a to the 5, and I've still got the 3 hanging around. And then the square root of a, you need to change to a to the half, so you can do your rules. Now you've got the division rule, which means you take away the powers. 5 minus a half is 4.5. Don't like mixed numbers, so I'll put 9 halves. So the final answer is 3a to the 9 over 2. And we're done. No need to put it back in a root because it's not asking us to. 2022, paper 1, question 11. M to the minus 2, all to the power of 4 times m to the minus 5. Leave your answer with a positive power. So I use the power rule, and straight away I get m to the minus 8, because minus 2 times 4 is minus 8, times by minus 5 as a power. Don't be tempted now to times these together. If it's times in indices, you add the powers. So I add the powers, minus 8 plus minus 5 is minus 13. But I'm not done yet because it says positive power. So I need to know my negative power means 1 over the positive version. In other words, 1 over m to the 13 for our final mark. And we're done.
So if it was to 1 decimal place, we would round after the first decimal place. So we need to cut here. The 6 terms I need to round up, so it would become 25.2, the next number. And for the second one, I need to round after the first decimal place, so I need to cut here, and the 3 terms I need to round down, so I get 413.6. We wanted to round that to 2 decimal places. Then we can imagine we're going to cut it here, and we need to round up because 4 is less than 5, so it's 25.16. Nice and simple, that one. The second one, 413.631, again to 2 decimal places. If I cut it here, then 1 tells me I need to round down, so it's 413.63. Rounding to significant figures. Let's say we wanted to round 1276 to 2 significant figures. Then we need to have 1. 7 tells me to round up to 3. The numbers was a thousands, so I need 1,300. Add zeros for the rest of the number. Let's try that again with another big number. 37,684 to 2 significant figures. So I'm cutting here. So I've got 3. 7 becomes 8 because the 6 tells me to round up. And then I need 1,000 because it's 37,000. Smaller numbers this time, so 0.06356. Well, I don't start counting until I hit a number. So the first significant figure is 6, the second one's 3, so I'm cutting here, so it's 0.06, and I need to round up to 4. And in this case, I don't have to add any extra zeros. The next one, 0.005832, so to 2 significant figures, I'd be cutting here, so I'd be getting 0.00. 5 and 8. Okay, standard form or scientific notation. So let's go. Big number first, 2530. So the first thing you always write down is a number between 1 and 10 using the numbers I've got. So it's 2.53, always times 10. Then a power. To get the power with this, you just count the number of numbers after the first one. So in other words, 1, 2, 3 to the power of 3. Nice and easy. Bigger numbers are quite simple. With smaller numbers, just the same idea. I've got 0.000058, so I've got 5.8 times 10 to the power. And I want to imagine this decimal point jumping 1, 2, 3, 4, 5. So minus 5, not positive, minus for numbers that are between 1, 0 and 1. Okay. And we can do calculations with standard form. We'll come back to this later a little bit when we do laws of indices, but very briefly, if I do this sum, I do 1.8 times 3, so you can get a calculator out if you want. 3 times 1 is 3, 3h is 24, so that gives me 5.4 times 10. And to get the power, Well, with indices, if the base is the same, you just add the powers. So 8 and 5 make 13. Division works in a similar way, so I divide the numbers. 6.8 divided by 2, that gives me 3.4 times 10. And then you take away the powers. 7 take away 3 is 4. Couple of past paper questions standard form. So 2016 paper 2 question 2. A pollen sample weighs 12 grams and contains 1.5 times 10 to the 9 pollen grains. Calculate the weight of 1 pollen grain in grams. Give your answer in scientific notation. So it's asking me for the weight of one of the things. So I need to divide by 1.5 times 10 to the 9 to find one of them. So the sum I'm going to do is 12 divided by 1.5 times 10 to the 9. And I'll put that in brackets to remind myself that when I get my calculator out, I'll need to use a brackets around it. So that's 12 divided by 1.5 to the power times 10 to the power of 9. That gives me 0.0000000008. So I just write that down. 0.00000008. I have to give my answer in scientific notation or standard form. So I just do that in the same way. 8 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9 minus 9. There are 3 times 10 to the 5 platelets per millilitres of blood. On average, a person has 5.5 litres of blood. On average, how many platelets does a person have? Give your answer in scientific notation. So I have to work out how many a person's got in total. I need to times. So I need to do 3 times 10 to the 5 times 5.5 litres, but I need to times that by 1,000 because there's 1,000 millilitres in a litre. 165, 1, 2, 3, 4, 5, 6, 7 zeros. So that equals 1.65 times 10 to the power of 9. 7 zeros plus 6 and 5 make 9. So let's start off with appreciation or depreciation with a quick example. Example 1. There are 964 pupils on the roll at Aberleven High School. It is forecast the roll will decrease by 15% per year. What is the expected roll after 3 years? And with the rounded answer to the nearest 10. With a question like this, if you notice a time and a percent, it is probably going to be this method, appreciation or depreciation. And the method's always the same. Start off by finding something called a multiplier. So a multiplier, very simply, is we start off with 100% and it's decreasing by 15%, so I take away 15%. 100 minus 15 is 85. And we turn that into a decimal. So 85% as a decimal, 85 over 100. Use a calculator if we need to, but 0.85 is what we get. Now the question is pretty simple. We take our number 964. We times by our multiplier to the power of the time, the number of years, 3. Now, we cannot do that in our head, so let's grab a calculator and see what we get. Here we are, so we've got 964 times 0.85. You're looking for your power button on my calculator as X, Y, and 3. And we get an answer, press equals just to make sure, 592.0165. So let's just copy that. 592.0165. And then just check to the nearest 10. Well, that equals 590. Nearest 10. Let's look at another example. Example 2 says bacteria in a test tube increase at the rate of 0.6% per hour. At noon there's 5,000. At 3 p.m. how much will be present? And with to give our answers to 3 significant figures. Okay, we need a time. Let's start with the time. Nice and simple. 12 till 3, that's 3 hours. Let's just take a wee note of that. And then we start our question. Same way as the last one. Find our multiplier. So, 100% plus 0.6%. Get a calculator if we need to. 100.6%. We need that as a decimal. So let's do that. 100.6% is 100.6 divided by 100. And, well, let's be careful and get our calculator just in case we make a mistake. Even I'll do it. 100.6 divided by 100. 1.006. Now the question's fairly simple. We just do the same as last time. We take our 5,000 in the question. We times by our multiplier to the power of the time, which again in this case was 3 hours. Get our calculator back. 5,000 times 1.006 to the power of 3. And there we are, 5090.54108. 5090.54108. 54108. So to 3 significant figures we wanted it. So that just means 509. Round it at this point. So that is 5090. To 3 significant figures.
So this is from a 2015 paper 2 question 1. A house is valued at £240,000. It's predicted to rise by 2.8% per annum. Calculate its predicted value after 2 years. Step 1's always the same. We need to find the multiplier, what we're going to times by. So we're starting off with 100%. And it's rising by 2.8%. So that gives me 102.8%. Now we need to change that to a decimal. So we'll do 102.8 divided by 100. And to be safe, I'll use a calculator. 102.8 divided by 100, 1.028. So that is my key number, that's my multiplier, because now what I'm going to do is take my £240,000 times my multiplier, and it's to the power of however many years of a time frame, so in this case 2. 240,000 times 1.028 to the power of 2. And I get 25362816. 253628.16. Last thing, don't forget your pound sign. Okay, now question 2017 paper 2 question 2 says a necklace is valued at £1,200. It is expected to increase by 4.5% per year over the next 3 years. Calculate its expected value after this time. Give your answers to the nearest pound. Be careful, remember to round. So let's start the same way. Our multiplier, 100% plus 4.5%. That's 104.5%. Change that to a decimal by dividing by 100. And this time I won't use a calculator. It's 1.045. There's our key number. Use a calculator just to be sure. So then we take the money, 1,200, times the multiplier to the power of the time, which is 3. So now we definitely need a calculator. 1,200 times 1.045 to the power of 3 is 1369.39935. Let's just write that whole thing down. 1369.39935, which equals to the nearest pound 1369 pounds. Okay, reverse percentages. So at National 5, in the calculator paper, there's generally 2 types of percentages question. The one we just did, where there was a time frame and what to times by the multiplier to a certain power. The other ones is where there's no time given at all in the question and you're working backwards to find the answer. Let's see it with an example. A car is valued at 3,780.
and this is 16% less than last year's value. What is the value of the car last year? Start off in the same way, guys. Multiplier. 100%. 16% less than went down, minus 16%. That gives me a grand total of 84%. So if we turn that to a decimal, we get 0.84, just dividing it by 100. So to find out the answer to the problem, we take 3780. Now, if we were finding out a new value, what it's going to be, we would times. The opposite of times is divide. So we divide by the multiplier. Here's a little tip for you. If there's no time in the question, you're doing a calculator paper, most of the time you'll have to divide. If there's time, you times. No time, divide. $37.80 divided by 0.84. Oh, 4,500. Nice round number. Put a pound sign in it. Done. Next example. James paid £297.50 for a laptop. The discount in the sale was 15%. Calculate the original price of the laptop. Start it in the same way. Multiplier. So we've got 100%. Discount in sales, a sales went down, minus 15% is 85%. Not always taken away. If it had went up in price, we would have added, but it's went down, so we're taking away. 85% as a decimal is 0.85. 85 divided by 100. So we just take our money, 297.50, divide by 0.85 to get back to the original price. Calculator is our friend here. £297.50 divided by 0.85, 350. Another nice round number. £350. And
okay, reverse percentages, but this time with a calculator. Still 2015 paper 2 question 8. It says James paid £297.50 for a laptop in a sale. The discount in the sale was 15%. Calculate the original price of the laptop. Here's a tip, there's no time in this question, so it's probably reverse percentages. We start off in the same way by doing the multiplier. So we've got 100%. It was in a discount, so it's been taken off, so minus 15%. That leaves 85%. Change that to a decimal in the normal way. Divide by 100 to get 0.85. So now, since we're going backwards, we're not going to times by 0.85 because we're going to try to get back to the original price. So we divide by 0.85. So 297.50 divided by 0.85. Calculator time. Exactly 350. So our answer is £350. Notice there's no time in this question. If you don't notice time, it might be divide. Look for things like original price. Venus and Earth are 2 planets in our solar system. The volume of Venus is 9.3 times 10 to the 11 cubic kilometres. This is 85% of the volume of Earth. Calculate the volume of Earth. Notice it does not say it's went down by 85%. It's just telling you that it's 85% of the volume of Earth. So 85% is our multiplier. Okay. So 85%, change that to a decimal. 85 divided by 100, 0.85. So we now just take our number, 9.3 times 10 to the 11, divided by 0.85 to get back up to 100%. 9.3 times 10 to the power of 11, divided by 0.85, and we get a huge number. So we've got 109,411,76,470,58.82 cubic kilometres. Now, Doesn't ask us to round it or anything like that, but it's not a very reasonable number. So I will, just for the sake of this, round this to the same degree of accuracy as the question, so 2 significant figures. So that gives me 1.1 times 10 to the power of, well, all the numbers after the first one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up to the decimal place, to the power of 12, and it's cubic kilometres, so kilometres cubed. Okay, same type of question here, but this time non-calculator. I can't use a calculator at all. So it's 2014, paper 1, question 9. This was from 480,000 tickets were sold for a tennis tournament last year. This represents 80% of all available tickets. Calculate the total number of tickets that were available for this tournament. I know that 80% represents 480,000. And I want to know what's 100% going to be. So I need to get down to 1% maybe, or 10%, and then back up to 100%. In this case, I can see that 80 does go into 480,000, so I'll find 1% by dividing by 80. 480,000 divided by 80. So I can knock a 0 off straight away. 8 sixes is 48. 1, 2, 3 zeros left over. So I've got 6,000 for 1%, and therefore 100%, just times them by 100. Making sure I get all my zeros in, 600,000. And there we are. Let's start with addition of mixed numbers. We've got 3 2/3 plus 4.5. So we can do 3 plus 4 to start with and get 7. And then we've still got 2/3 plus 1/2. Adding fractions means we need a common denominator. Easiest way to do that is times the denominators together. So 2 times 3 is 6. And a nice way to visualise two fractions times together, well, 2/3 has been times by the bottom denominator 2. 2 times 2 is 4. And 1/2 has been times by the other denominator 3. So 1 times 3 is 3. So I get a little cross. 4 plus 3 equals 7 over 6. Which I can change to a mixed number, 1 1/6. So putting my answers all together, 3 plus 4 is 7, plus another 1 is 8, and 1/6. And we're done. Alternatively, you could have changed each of the fractions, the mixed numbers, to improper fractions, and then added them, but then you would have had to simplify your answer, and you could leave your answer as an improper fraction, or you could change it back to a mixed number. Okay, let's look at a couple of examples of subtraction of mixed numbers. So I've got 4 2/3 minus 3.5. So I can do 4 minus 3 to start with and get 1. And then I've still got 2/3 minus 1/2. So again, common denominator, 3 times 2 gives me 6. 2 times 2 is 4. 1 times 3 is 3. 4 minus 3 is 1. So I get a 6th. So the final answer, just putting it together, is 1 1/6. Let's look at the second example. So the second example says 7 1/5 minus 2 1/3. So I can do 7 minus 2 and get 5. And I've still got 1/5 minus 1/3. So common denominator, 5 times 3 equals 15. So I get two fractions with 15, a minus in between. 1 times 3 is 3. 1 times 5 is 5. Notice this time I get 3/15 minus 5/15. So the answer I get is a negative answer, minus 2 over 15. So if I want to put that together, I've got 5 take away 2/15. So I drop down to 4. And if you imagine a pizza, I've got 15 slices. I take away 2 slices. So I've got 13 slices left over. 13 out of 15. Of course, there's other ways to do these. This is just one way. Again, you could have turned them into improper fractions first and then just took away and then simplified your answer. And you could leave your answer as an improper fraction or a mixed number. And there's obviously other ways as well, but this is just one way. Okay, let's multiply some mixed numbers. When you've got 3.5 times 2 1/5 there. Now, common mistake here, don't make it. You cannot do 3 times 2 1/2 times 1/5 because you've missed some of the sums. because you've not then done 3 times, say, a fifth, or you've not done 2 times a half. So to avoid all that nonsense, we always turn, when it's times and divide, fractions, mixed numbers into improper fractions. So let's start there. 3 and a half, so I do, how many halves make 3? 3 times 2, that's 6, plus an extra 1. So I've got 7 halves times. And the same with the fifths, I'm asking how many fifths are in 2? 2 fives are 10, 10 plus an extra 1 makes 11. So I've got 11 fifths. And now the sum is very simple. You can just times the top and times the bottom. If you can simplify at this stage, you can, or wait to the end. So I'm just going to times 7 times 11 is 77 over 2 times 5 is 10. And at this stage, you can either simplify your answer and leave it as an improper fraction, or you can change it back to a mixed number. I'm going to change it back to a mixed number just for the fun of it. So 10 goes into 77 7 times with a remainder of 7 left over. So 7 7/10 would also be a good answer. Okay, division works in a very similar way to timesing, but there's a little thing you have to do as well. The first thing I'm going to do, any mixed numbers will change to improper fractions. So we've got 3/4 to start with, divided by, well, I've got fifths, so I've got 5 fifths plus 2 fifths makes 7 fifths. Or, to put it another way, 1 times 5 plus 2 is 7. Now, divide. To divide by a fraction is the same as multiplying by its reciprocal. What does that mean? Well, it just means you do 3/4, divide turns into times, and 7 fifths turns into 5 sevenths. It flips upside down, I suppose you could think it. 5 sevenths. And now it's easy. 3 times 5 is 15. 4 times 7 is 28. Little check at the end, is there any numbers that go into 15 and 28? No, I cannot. There's no numbers that go into 15 and 28, so I'm done. Okay, 2018 paper 1 question 1, quite a common question to turn up. Evaluate 2 1/3 plus 4 fifths. So the first thing I'm going to do is do my third plus my 4 fifths. 3 times 5 is 15. So that's my common denominator. 1 times 5 is 5 for the first fraction. 4 times 3 is 12. Putting it together, I get 12 plus 5 is 17 over 15. Changing it back to a mixed number, I get 1 and 2/15. Because 15 goes into 17 one time with 2 remainder. So the answer to the question, I've got 2, remember. So I've got 2 plus 1 and 2/15, which means I've got 3 and 2/15. So again, remember, the other way you could have done this question is to change the 2 1/3 into an improper fraction and then added and simplified. Okay, 2015, paper 1, question 1 again, so non-calculator. 6 1/5 minus 2 1/3. So the first thing I'll do is I'll deal with the whole number parts. So I do 6 take away 2 and I get 4. Now I can do a fifth minus a third. Common denominator is 15. 1 times 3 is 3. 1 times 5 is 5. 3/15 minus 5/15. Don't make a mistake, it's not 2, it's minus 2/15. So when I get a negative answer, then my final answer, I started with 4, so I drop down to 3. Imagine again, I've got 15/15, 15 pieces of pizza. I take away 2, so I've got 13 left over. So I've got 13/15 left. One quick and easy way to think of that is, if you look at the denominator 15, 15 take away the numerator 2 is 13, so it's 13/15. Okay, 2016, paper 1, question 2. 3/4 brackets 1/3 plus 2/7. So BIDMAS gets involved here. I do the bits inside the brackets first, then I times the bit outside. So the first thing I'm going to do is 1/3 plus 2/7. Common denominator is 21, 3 times 7. 1 times 7 is 7, plus 2 times 3 is 6. 7 plus 6 is 13, so we get 13 out of 21. We've got 3/4 times the answer we just got, 13 out of 21. Now at this stage you can simplify after you do the times or before. You can always simplify with a times, but you can't do it with an add for fractions. So here we go, we can simplify by dividing by 3 to get 1, divide by 3 to get 7. Now the sum becomes a lot easier. So that means we've got 1 times 13, and we've got 4 7s is 28. 13 out of 28. Just double check if there was any more simplification I can do. I know there isn't, but there's no numbers that go into 13 and 28, so I'm done. Okay, 2017, paper 1, question 3 says, evaluate 1 5/6 divided by 3/4 and give your answer in its simplest form. So we change the mixed numbers into fractions first. So 1 5/6, 1 times 6 is 6, plus 5 is 11. So that becomes 11 over 6 divided by 3/4. So that becomes 11 over 6. Dividing by a fraction is the same as timesing by its reciprocal. So flip the second one upside down, 4/3. We can now simplify in advance or at the end. So I can divide this one by 2 to get 2, this one by 2 to get 3, and then our final answer becomes 11 times 2 is 22, 3 times 3 is 9. Just double check there's no more simplification. There is not. At this stage I can leave my answer like that. I do not have to change it back to a mixed number, so that's fine. If I did change it back to a mixed number, I would get 2 4/9. 2022, just last year, paper 1, question 1, evaluate 2/5 times 1/5 plus 3/4. So again, BIDMAS brackets first. 1/5 plus 3/4. Common denominator is 20. 1 times 4 is 4, plus 3 times 5 is 15. 19 out of 20. So we've still got this 2/3 to times by. So step 2, 2/3 times 19 over 20. 2 times 19 is 38. 3 times 20 is 60. And they're both even, so I can divide by 2 to simplify. A half of 38 is 19, and a half of 60 is 30. 19 is a prime number, it doesn't go into 30, so that's me simplified for my final. It's been Mr. Clare on Maths, and today we'll be looking at the 2023 National 5 Maths exams. Hopefully that was helpful for the numeracy unit. Stay tuned for the next 3 videos. Take care, stay safe, and goodbye.